In this video, we will be looking at object-oriented programming and the definition of classes from UML class diagrams. So let's now look at the details of the task. Vehicles is a generic name given to the types of motorized transport that use roads each day. Common characteristics of those vehicles are the annual tax cost, does the vehicle have valid insurance, and who the registered keeper is. And the task in hand is asking us to write the pseudocode for the vehicle class. So let's now just take a moment to look at the UML class diagram. In the first row we have the class name. The first section we have the attributes of the class vehicle. Remember, attributes are sometimes known as fields. And then we have the methods of the class vehicle. We have the constructor method. We can identify it as a constructor method due to the word new, public new. So let's now just look at a few slight variations of this diagram compared to standard UML class diagrams. Now, the formatting of this UML class diagram comes from the examination body. Most UML class diagrams will have simply the name of the class as so. It will not have the word attributes or methods, and instead of the word private they would generally be replaced with a minus sign for the identification of a private field, and public fields would be identified with a plus sign. So the reason why I've included that is in case you're learning about object-oriented programming and you pick up a book and you turn to a UML class diagram, notice that it has minus signs and plus signs to replace the word private with minus, public with plus. I believe that's a simplification from the exam board. So I'm just going to put those back in just for clarity's sake. So we've got a match against the examination board standards. So now what we're going to do is we're just going to have a look at the individual fields or attributes. So we have 3 private fields. Just to recall, private means they are encapsulated. It promotes encapsulation. Therefore, to access these attributes, they must be done using the getter and setter methods, or sometimes known as accessor for getter methods, and setter methods are sometimes known as mutators. Interchangeable terms there. So we notice that the private annual tax cost is defined as the primitive data type float, valid insurance is Boolean, and registered keeper is a string. Our constructor method, remember constructors are specialist methods that create objects from classes, requires 3 parameters for annual tax cost, valid insurance, and registered keeper. And for simplicity's sake, you'll notice that I've put the setter and getter methods together for each field. Remember, setter methods are also known as mutators, getter methods are also known as accessors. Generally speaking, setter methods will require a parameter, the taking data to the subroutine, the method, and then assigning it to the field or attribute. The getter methods will have a return type, so you'll notice that I've used a colon here and then the return data type following the method header definition. So we can see this case, get annual tax cost returns a data type of type float. get valid insurance returns a data type of type Boolean. Get registered keeper returns a data type of type string. So now we're going to look at the pseudocode implementations of this class definition for vehicle. So now let's look at the pseudocode implementation for the class vehicle. So on our first line of code, you can see the definition of class and the class name vehicle. And then we have our three private fields as defined in the UML class diagram. Then we have our constructor method. So let's look at the coding behind our constructor method. We're going to quickly browse over this because that was covered in a lot more detail in the previous video. So please feel free to go back to the constructors video in this channel. So our constructor takes the three parameters. Remember, P is just used to quickly identify the data that's been passed to this method as a parameter, and the parameters are assigned to our fields or attributes. So that's our constructor for method vehicle. So we're now going to look at the coding of some of the methods. So we have a public procedure. Remember, procedures don't have a return type. Set annual tax cost. So this is a mutator method. We're going to change the contents of the attribute annual tax cost. So therefore we are going to take the parameter P annual tax cost and we're going to assign it into the attribute annual tax cost. And that is the end of that method. We've then got a getter method, also known as an accessor, for the tax cost. Notice the absence of a parameter. It does not require one, but it does have a return command. So that's important. Obviously, functions return values. In this case, it's returning the contents of the annual tax cost field or attribute. Very similar setup for our procedure set valid insurance. We have our mutator method taking the parameter P valid insurance, assigning it to the attribute valid insurance. That is the end of that procedure. Then we have our accessor method, our get valid insurance, again does not require a parameter, and it returns the contents of the attribute valid insurance. So we have our return command as usual, and exactly the same format for our procedure set registered keeper. We have a mutator method which takes the parameter pKeeper and assigns the contents of the parameter pKeeper to the attribute registered keeper. So that is the end of that mutator method. So the accessor method for getting the registered keeper, again, does not require a parameter, but returns the contents of the attribute registered keeper. So this is the end of the function get registered keeper, and then simply end the class with the line end class vehicle. So if I quickly just scroll down again so people can review the class. So we have our class header. It's very important that you stick to the order of fields, constructor, methods. That's the formal standard that you would expect to see in a class definition. Of fields first, followed by the constructor, followed by the appropriate methods.